Hello everyone, this is Ashok, your personal guide and mentor. I welcome everyone to my YouTube channel A.K.B tutorials. Here we are going to discuss and cover some important concepts of mechanical engineering that are very useful and helpful for competitive exam and job interviews. So let us start today's session. Okay, hello friends. Today we are going to learn one of the most important topics of strength of material. That is the various properties which is used in the subject. So we'll see the properties one by one. And before going to that, so we'll see the various assumptions made on the derivation of the equations in strength of material. Okay, so assumptions are made to simplify the calculation. Now, in real cases, there may be so many problems, so derivation is not possible if we consider the real cases. So that's why the assumptions are made to simplify the calculation. So now the various assumptions. The first assumptions, the material of the body is homogeneous and isotropic. So this is the first assumption. So if we consider the homogeneous, that means the chemical composition throughout the body is same. That means at every point the chemical composition of the body is same, then the body is said to be homogeneous. And second is the isotropic. If the property value in all the directions is same, then the material is called isotropic material. So whatever material is assumed here in our derivation is homogeneous and isotropic. Next, the line of action of the force is passing through the center of gravity of the body. Force is acting, say over a surface, force is acting over this surface, the force is acting. So if we show the force is acting here, now if the center of gravity is here, so it is passing through the center of gravity, or number of forces are acting, then line of action of the resultant force is passing through the center of gravity of the body. Next, the load is applied gradually over the body. So in last video we have seen what is gradually applied load. So the load which is applied from 0 to maximum value, that means that load takes some times for loading. So that kind of load is called gradually applied load. So until unless it is told, so we will consider for all the derivations that load is applied gradually over the member. Next, the load applied on the member is within elastic limit. Okay, so load will not exceed the elastic limit value, and the load is distributed evenly over the whole surface. Say over this surface, if F load is applied, it is distributed evenly over the whole area. So that is the meaning. And next is the self weight of the member is neglected. Now we will move to the properties. The various properties we will say here. So the first property, so before this we will see what is known as mechanical properties. So the mechanical properties. So what is the definition of this? What is mechanical properties? Because we are in mechanical engineering, so we should know what do you mean by mechanical properties. So the properties which are related to load bearing capabilities of a material is called mechanical properties. So the properties related to load bearing capabilities of a material is known as mechanical properties. So that means under this heading mechanical properties, whatever properties we will discuss, so every property is related to load bearing capabilities of the member. Now we will see one by one the various properties. The first property we will see is rigidity. This property, by virtue of this property, the body will not deform at all under the action of a heavy load or any load. So that means if the body is loaded with a heavy load, say F, then also the body will not deform at all. So the property by virtue of which the body will not deform at all, that property is called the rigidity. And this is the main concept considered in engineering mechanics subject. Now we will see the next property, that is elasticity. So this is the property by virtue of which the body will come back to its original shape and size when the external load is removed. Consider a body. The body is under external load. As the load is applied, the body will deform by some amount, and as soon as this deforming force is removed, so body will come back to its original shape and size. This property is known as elastic property, and almost all the materials shows this behavior up to certain limit. Okay, beyond this limit, the body will not show elasticity, it will show plasticity property. Anyhow, next property is the plasticity. This is the property by virtue of which the body can retain some deformation within it even after removal of the external load. So this property is essential mainly for metalworking operations. Okay, so this is the property by virtue of which the body can retain some deformation after removal of the external load. And the next property we will see the viscoelastic property. So this is the property by virtue of which the body will come back to its original shape and size, but not instantly. So in case of elasticity, As soon as the load is removed, body will come back to its original position or original shape and size. But in this case, that is in case of viscoelastic property, the body will not come back to its original shape and size instantly. It will come back to its original shape and size, but with some time. That time may be in second, time may be in minute, time may be in hour, or it may be in days. Okay. So some plastic like material shows this behavior, that is called the viscoelastic property. Next important property we will see is ductility. This is the property of material by virtue of which the body can be elongated to a thin wire without cracking or crack formation. So, under tensile load, this is the body. Now, if the body is under tensile load, the elongation of the member will take place if we carry on increasing the load. So under this load, the body will carry on increasing to a thin wire without cracking or without any crack formation. So this property is called the ductility. Ductile materials, the behavior, this ductility behavior, the material which shows this behavior is called ductile material. Like mild steel, copper, aluminium, etc. shows this behavior. So these materials are called ductile material. The material which shows this ductility behavior is called ductile material. Now next property is brittleness. This is the property by virtue of which the material breaks easily without much deformation. So this is the property by virtue of which the body will break easily without much deformation. The material which shows this behavior is called brittle material, like cast iron shows this behavior. So the property by virtue of which the material breaks easily without much deformation, and the material which shows this behavior is called brittle material, like cast iron. Next we will see the another property, that is the hardness. The property by virtue of which the body resists, the property by virtue of which the body can resist indentation, penetration, abrasion, and cutting action. Is known as hardness. The property by virtue of which the body can resist indentation, penetration, abrasion and cutting action is known as hardness. And the hardness is tested. The hardness of a material is tested by first one is the Brinell hardness testing machine. Rockwell hardness testing machine, Brinell hardness testing machine, Rockwell hardness testing machine. Then Vickers hardness testing machine, and also by using source celeroscope. Testing machine. So these are the various machines used to test the hardness of the material. Now hardness is the property by virtue of which the body can resist indentation, penetration, abrasion and cutting action. So these four words used here, that is indentation, penetration, abrasion and cutting action. These are the various principles by which the hardness of a body is measured, and the hardness of the body is tested by these methods, that is Brinell hardness testing method, Rockwell hardness testing method, Vickers hardness testing method and source celeroscope testing method. Now we will see another property, that is malleability. This is the property by virtue of which the body can be beaten into a thin sheet without cracking. So that means if this is the body, initial body, now if the compressive load is applied, the body can be beaten, means compressive load, under compressive load this body can be beaten into a thin sheet without any crack formation. So that property is called the malleability. Next property we will see, that is the most important property, that is the strength of the body. So next property is the strength of the body. What is strength? This is the inherent property of the body. This is the property by virtue of which the body can resist the maximum resistance before failure. So the maximum resistance offered by a body before failure is called the strength. It is expressed in stress term, and if we see the stress strain diagram of a body, so say this is the stress strain diagram of a ductile material, and the maximum resistance offered by the body is denoted by this point. This is known as sigma UTS, that is ultimate tensile stress. So the strength of the body is the ultimate tensile strength. But in mechanical engineering, we are considering this one as the strength of the body, that is sigma Y, that is upper yield point stress, as the strength of the body as far as mechanical engineering is concerned. Why? Because if this point is exceeded, then after removal of the load, there will be some permanent deformation present in the body. So, if any permanent deformation present in the body, as per as mechanical engineering, the body has failed. So, that's why sigma y is considered as the strength of the body as per mechanical engineering. But actual strength of the body is sigma UTS, and this is expressed by stress term. Now, we will see that is called toughness of the body. What is toughness? The energy absorbed by the body before failure is called the toughness of the body. The energy absorbed by the body before failure is known as toughness of the body. It is the fluctuating load carrying ability of the body. So, toughness is the fluctuating load carrying ability of the body. Now, if we find the area up to failure point under stress strain diagram, this is the area under stress strain diagram up to failure point. This area indicates the toughness of the body per unit volume. So, toughness is given by is equal to, so if we find the average stress, say this is sigma average, see sometimes the stress is this much, sometimes this much, sometimes this much, sometimes this much, and this one, so average stress becomes say this one. So, we can find, so sigma average into strain at breaking point into volume of the body. So, this is the toughness of the body. So, toughness of the body is given by sigma average into strain at breaking point into volume of the body. Okay, it is the shock load carrying ability of the body, and it is given by the area under stress strain curve up to failure point per unit volume. So, if we multiply with volume, then this will give you the toughness of the body. Okay, next we will see the another term, that is another property, that is called stiffness. So, what is stiffness? See, this term is mostly used in springs. This is defined as the stress required per unit deflection. Say, we are drawing a load versus deformation. This side indicates the load and this side indicates the deformation. So, within elastic limit, if we see, it will give a straight line curve. Now, what is stiffness? See, say this is for material A, and for another material, if we see, say for material B, this is the curve. Now, per unit deformation, if we draw a vertical line, so we can see the load required for curve A, for material A, is more than material B. So in this case we can say material A is more stiffer than material B. So that means, what is stiffness? It is the load required per unit deflection. So the load required per unit deflection is known as stiffness. Next, we will see another property, that is resilience. What is resilience? It is the energy absorbing capacity of a body. So the energy absorbed by a body within elastic limit is called the resilience of a body. The energy absorbed by a body, within elastic limit so is known as resilience. Now if we see the stress strain diagram, say this is the stress strain diagram of a body, and within elastic limit the curve will be a straight line. Now if the body is loaded up to this point, so this will be the strain developed in the body. So this is the strain developed and this is the stress. So this side indicates the stress and this side indicates the sigma. The energy absorbed by the body up to this is given by this area, that is within elastic limit. So under stress strain curve, if we see, this is the energy absorbed by the body per unit volume, that is given by half into stress into strain into, if we multiply with volume, then that will give you the resilience of the body. So it depends on the stress developed on the body. So that means if the load is increased, so that means the energy absorbed will also increase. That's why it is written as within. Now next is the proof resilience. Next one is proof resilience. So this is the energy absorbed by the body up to elastic limit. So proof resilience is the energy absorbed by the body up to elastic limit. Say this is the elastic limit, so this is the energy absorbed by the body up to elastic limit. So this whole area per unit volume will give the, so it is written as half into, say, sigma E is the elastic limit stress and epsilon E, that is strain at elastic limit, into volume of the body. So this is the proof resilience. And the next one is the modulus of resilience. So that is the proof resilience per unit volume is called the modulus of resilience. Proof resilience per unit volume. So it is given by, so this is the proof resilience and if we divide this by the volume of the body, it will give you the modulus of resilience, that is given by half into sigma E into epsilon E. Next, we will say that is called modulus of fracture. This is the energy absorbed by the body up to breaking point per unit volume. That is modulus of fracture. This is the energy absorbed by the body up to factor per fracture per unit volume. Okay. This is the energy absorbed by the body up to fracture per unit volume, and this is given by the area under stress strain curve up to failure point. So this is given by the area under stress strain curve up to failure point. And we will see the last properties as per me. So let's see, that is creep. So as per its definition, that is slow but permanent deformation at constant load within elastic limit. Within elastic limit for a longer period of time at elevated temperature. Is known as creep. Slow but permanent. This deformation takes place very slowly, but this is a permanent deformation at constant load within elastic limit. Load value is within elastic limit. So if load value is within elastic limit, permanent deformation will not take place. But in this case, that is in case of creep deformation, so permanent deformation takes place within elastic limit. Load value is within elastic limit, then also the permanent deformation takes place. For a longer period of time, when the body is loaded with that value for a longer period of time at elevated temperature, at very high temperature. And mostly this deformation found in, that is, turbine blades, heat pipes, boiler cells, etc. So that means in this case, slow but permanent deformation takes place at constant load within elastic limit for a longer period of time at elevated temperature. So this definition, this property is called creep, and this deformation is found in turbine blades, heat pipes, boiler cells, etc. Okay friends, so this is all about this video, and we will meet you in the next video. Thank you. That's all for today's session. We would continue further on this topic in the next session. Keep being connected with us and ask any question in the comment section. Like, share, subscribe, and don't forget to press the bell icon to get notified for future videos. Thank you and see you soon.